happens when one clock is in motion. Notice although both clocks are identical, the moving clock ticks slower than the one at rest. In order to understand why, notice the paths of the light beams. The light in the stationary clock travels up and down vertically, but the light beam in the moving clock must travel a longer diagonal path.
They thought he was a goof-off. They didn't know he was a genius. So here he is working in the patent office, daydreaming as usual. He sees some men working on a roof, and he imagines if that man fell off the roof, he would be weightless. Weight is dependent upon mass. Mass can be measured in pounds or kilograms. I like pounds. I'm an American. I'm not ashamed to be an American. If that man working on the roof weighed 200 pounds and he fell off the roof and was falling through the air, according to Newton's equation of gravitation, the mass of the earth and the mass of that man are attracted inversely proportional to the distance between them. And that man is getting faster and faster. He's falling faster. He's accelerating. He ain't weightless. Einstein was riding on a train, and apparently as he left town, he got a glimpse of the clock tower in the middle of the town on some building. And the train went down the track, curving around and going through the mountains. And then he got a second glimpse of the clock at a distance, and he'd started daydreaming. What would it be like to move away from that clock at the speed of light? I bet the clock would stop. And he concocted a formula that basically illustrates that. And that was that formula, the square root of 1 minus a fraction, which is velocity squared divided by the speed of light squared. That formula, if you were traveling at the speed of light, not only would that clock stop, even 10,000 years of human history would stop and equal zero, according to that formula. If you plug in the speed of light to Einstein's formula, the one I showed you earlier, and here it is again. You plug in the speed of light, this fraction here becomes 1, and 1 minus 1 is 0. The square root of 0 is 0, and any number, whether it's 1 second or 1,000 years or 10,000 years or a million years, any number multiplied times 0 equals 0. Therefore, t prime equals 0. That's the time on the clock that's moving at the speed of light. The fast clock is 0 if viewed from the stationary position on the Earth. If you look out across space into some kind of a very fast space vehicle, if you could see the clock, it would be motionless, according to this formula, which is supposedly derived from Pythagoras. The Pythagorean theorem is a very simple and very helpful mathematical formula used by carpenters, among other people, to very quickly and easily determine if the foundation of your building is square. If you want to check a corner for squareness, you measure out 3 feet, for example, and then measure along the other wall from the corner 4 feet. If that corner is square, if it's a right angle, if it's 90 degrees, the diagonal, which is the hypotenuse, should equal 5. And you can use multiples of 3, 4, 5 to get that result. And it so happens that Pythagoras, a Greek mathematician 2,000 years ago, arrived at that conclusion, which is very helpful in construction, that the side A squared plus side B squared equals the hypotenuse squared. Therefore, if you don't know any of those three, you can use a formula. If you're looking for the hypotenuse, for example, it would be the square root of A squared plus B squared. There's no way that I can see that Einstein derived his formula about the time dilation, or however you want to call it, fast clock syndrome, which supposedly is true. I don't believe it. There's no way he derived that from the Pythagorean theorem. And even if he did, at the speed of light, the time on the moving clock is 0. That's quite a bit different from a ziggity-zaggity line going through space, as illustrated by a special clock which uses 2 mirrors and the light beam going between them, and as it moves, then supposedly the light beam would make a zigzag, zigzag, zigzag. No, if time is 0, that light stops. That clock stops. It doesn't stretch out infinitely. And if the spaceship were to accelerate, why would the light alter its course? Why wouldn't the light keep on going and the mirror move out of the way and the light go right up and miss? The light would have to alter its course and make a zigzag. The light's not going to alter its course by itself just because you speed up a spaceship. If you flash a flashlight inside, say you're in a bus or an airplane, or you throw a rubber ball at the ceiling or at the wall, while that airplane or that bus is in motion. The ball is going to pretty much hit its target. If you throw a rubber ball at a moving target, say it's the side of an 18-wheeler, say you're standing beside the highway and a 18-wheeler is going by at 100 miles an hour, and you throw your ball at it at 100 miles an hour, your ball is not going to hit the truck because the truck will have moved by the time your ball reaches the truck. Your ball will keep on going. Anybody that's ever thrown a football in a football game knows that the quarterback has got to lead the receiver. He's got to throw that ball where he anticipates the receiver is going to be by the time the football reaches the receiver. That type of thing. Einstein was a klutz when it came to practical matters. He daydreamed and he saw optical illusions and surmised that these optical illusions were clues to reality.